Great. So to make this easy on myself, I recorded the the GUI demo, but you'll get the real-time voiceover of it, and I'll have to hit the space bar a couple of times undoubtedly.
So I just got 2 slides to set context, and then we'll do a demo. We'll break, give you some detail about how we're doing these things, show another demo, which will be about the scaling and the performance, and then we'll go into that side of it as well. Okay. So we kind of talked about this, and there's 3 key capabilities that we get because of this architecture. They're very unique. Yep.
I see add inputs. And you manage the add input at the node level, so at the single
Yes.
rack unit level? Okay.
Yes.
So you have
So we have software everywhere, okay? Which is, one of the things maybe I skipped over or glazed over is when you look at that architecture, we sit both on every storage node and we sit on every hypervisor or server that wants to access that pool. And that's the reason we can do this optimization. That's the reason why we can deliver this end-to-end quality of service. If you're not at both ends, you can't optimize. That's the big problem everybody has. VMware, Hyper-V, or Microsoft, they can't do it. Okay? They're only at one end. They're relying on other people to do things at the other end, but you're never going to optimize. You're always going to have a lowest common denominator there. So by being at both ends, we're able to do the kind of things. And that's really why these 3 capabilities are so unique to what we have today. We can optimize each VM. And if you think about what happens with every application, they've all got an optimal I/O pattern. And what we're doing is effectively detecting what that pattern is and optimizing for it. The quality of service, as I said, we tag it, we move it across. You can put that quality of service right onto the network, so the network has the same quality of service going across, and then up into the storage. And the last is this grid scale, so we'll talk a bit how we can scale this. We talk about 2 types of pools here, the capacity pool and a hybrid pool. Over time, we anticipate growing the types of pools. So you can imagine a kind of a deep archive pool. And at the other end of the extreme, a pure flash pool, where you want absolute performance. So this is kind of the spectrum of resource types that we see. The first 2 that we have, are focused on capacity optimization and performance optimization.
The pools are shared across all the Gridstore storage nodes?
The pools, I'm going to show it. One limitation, we don't mix nodes. So you'd have a set of nodes that are capacity oriented, okay? So that just blocks of capacity,
right.
Good for streaming I/O and so on, and then blocks of hybrid, okay? We don't mix those across each other. That's the only limitation.
You may have said this earlier, but is that an administrator-defined pool, or are those dynamic, based on what the system sees?
The nodes actually are tagged when they come in, so they don't actually have software on, they just have a type. They'll automatically go to the right pool, get software loaded onto them, add themselves to the grid.
Oh, okay, so you're not dynamically generating pools from what you see in the underlying storage. It's based on what hardware ships.
It's what the hardware is, but which creates your overall pool. Then you can carve out, we call virtual LUNs, which we're going to show you in the next demo.
It's a group of nodes.
Yes, that's a group of nodes, okay? And then inside of that we call virtual LUNs, which then you can be shared out. And that's again on a specific set of nodes. I'll take you into those.
Speaking about capacity pools, which is a combination of nodes, are all the nodes the same configuration? For example, if it's a 4-disk unit, do they all have to be 3 terabyte disks over all the nodes in the pool, or can you, if next year we have 6 terabyte disks, can we add that in the same capacity pool?
You can. Yeah.
Okay.
And you can mix, like we have 2 chassis right now. One is a 2 drive and one is a 4 drive. They actually come with different size disks in them.
Okay.
So you can do that.
6 terabyte disks right here. So.
Yeah, okay.
So these are the 2 types of nodes that we have, which is, the hybrid, which is it's got 12 terabytes of backing capacity of SATA. It has about 600 gigabytes of PCIe flash sitting on top of that, which we use in a write-back configuration. We use a lot of RAM, because we're going to talk later about how we use that. We can be very aggressive.
2 gig isn't a lot anymore?
No.
It is when you start to add it up.
Per node?
Yeah. It's a lot for one node. And everything on them is serviceable. So, we'll talk about the protection schemes. You can fail entire nodes, but if you fail just a disk or a power supply, you can hot swap those out as well. The capacity or C-class nodes are basically built on the same platform. They just don't have the PCIe flash on top of it. Okay. So I'm going to hand over to Don, who's going to just take you through the kind of setup and installation so you can actually see what it looks like.
So you mentioned serviceability. If a PCIe flash crashes, you take out the node?
Yes.
How you service it?
That you would, yes.
Yeah, we'll deem it dead until the flash is replaced, because its IOPS will have changed so significantly without the flash in there. Yeah.
Till version 2.0
Great.
when they go with NVMe
sorry, wrong
and
one.
we can swap them out from the
Wrong
front.
Now, the good news is on that, the data is always safely tucked away in the rotating media and rated. So anything that goes into flash, it's not the actual data that now is residing in flash, it's just a copy of that block that you were asking for, right? So
I thought it was a write-back.
flash is a cache. It's an SSD cache, and we are not using the antiquated automatic tiering algorithms exactly.
Write-back cache?
Yeah, but I mean,
or-
it's a
write-back
tier,
cache.
so data
A
is not
write-back
staying
cache.
Okay,
It's
so
a cache.
if it's a write back cache, there's dirty data. That isn't on the spinning
good point,
disks.
Howard. We not only cache the reads, but we also have a write-back cache implemented, and we can show you the details on how that works.
That's
The nature of the grid made it easy for us to deliver that, and I think that's coming up.
Yeah, it is.
Right.
We've
Great.
got some specific detail on that for you.
Right, but data is written to 2 nodes, right?
3. 3 is the minimum.
3 is minimum.
Okay, so if there's dirty data in the cache in a node,
We can
okay.
take care of it.
yeah, then you're covered.
Yeah. All right.
Okay, yeah, sure. And then I'll just pause with the spacebar. So the first thing I'm going to show you is the virtual controller will be installed onto each of the clients of the grid. So these would be Windows servers or Hyper-V hosts. So there's my MSI file. I'm manually installing it here. But of course, you can do a silent install, push this out through Active Directory group policy as well. And so each of the Windows servers or Hyper-V hosts will get this installed on it. And there we go. We're done with that. Next demo. Let's configure some storage nodes. Well, to do that, we're going to need to bring up the grid control, which is our MMC snap-in. So we go to Administrative Tools, bring up grid control. And when it comes up, it's going to look for storage nodes. Now, when you first turn a storage node on, it throws up a beacon and says, I'm here, I'm looking for a boss. And so they should be reporting in to the grid control. There we go. So 4 storage nodes have reported in here, and now we're going to take control of them. First thing you need to do is assign things like, okay, we got a question, so I'll just hit pause here.
paused
Oh,
it.
thank you.
Where's the grid control reside? Does it reside in the driver?
It can be on any machine. It doesn't even,
server, or
Yeah.
is it on the storage nodes?
yeah, it would be on a server, on one of the Windows servers, or you might have it off on the
Is it a
side
single
on like
instance
Windows
or
8.
multiple instances of the grid control?
Just one instance at a time.
And it's only used during configuration, startup, and termination? Is that?
Well, you'll see in the course of the demo the other places where I use it, but yeah, it's for the really deep things that you want to do with the storage, because once we've presented the storage to the Windows server and we appear as a local SAS drive, hey, it's all Windows tools. Yep,
Okay,
that's
but
the joy of
But
it.
it's not in the data path.
It will not
it's
be in the
not
data
in the
path.
data
It's
path.
just for management, exactly.
And you
control.
can
So
run
we
it from
have it
any.
running on the Windows host as well as on the storage node, to answer your question.
Yes, you can run it from anywhere.
Well, it's certainly communicating with the storage nodes, right? Because it's managing them. Over here.
What functionality will you lose if this is not available?
Everything will run. You just won't be able to make changes, but everything will run. Yep.
And it doesn't run constant. It's only for administration. Yeah.
Okay.
So it
So
doesn't have a service or anything.
No.
It's only the GUI. Okay.
There is a management service that sits with the nodes, so which is a management looking at what's happening with the actual data plane.
that this is
which
connecting
separate.
to. Yeah. Okay, so now what we're doing is we're establishing a group of TCP/IP addresses, and it's good to have a profile because you don't want to have to do these steps for every storage node that's entered into the grid.
And that
So you just
range
create
is
a
for the
profile
storage
and give it
nodes?
a name. And
Okay.
you got it? Okay. And so now that we've got a name for the profile called Gridstore Profile, we select the nodes we want to have that profile and slam all of the information down into them. Now they're fully configured. They're under grid control, and we are ready. We're ready to start using the grid. So we'll go in, and the next step of this demo is we will create a Vlun. So just right-clicking over on Vluns. There are none right now. So just right-clicking, we create a new one, and just give it a name. Any old name will do. Vlun 01. It's fine. Give it a size. I believe I went with 400 gigabytes. It was getting kind of late, but I think that's what I remember.
Okay, and what's the grid protect level?
Okay, so that is, okay, now grid protect level. I want to pause on that. Oh, perfect. Thank you very much. Okay, you know RAID 5, you can lose one drive. RAID 6, you can lose two drives. We also have Reed-Solomon encoding, so you can lose any number of drives up to half minus one. So if you have data that for regulatory or compliance reasons needs to be around for 10 years, 15 years, 20 years, there are some bloggers out there that are saying that RAID 5 and RAID 6 is no longer adequate protection for such, you know, to keep data that long. Yeah, including, yes, some blogs I've read recently. That's why I bring it up. And so what do? If you feel like your data is going to go missing, you make multiple copies of it. So now you bought your storage again and again and again. We have found customers with 6 copies of their data, 8 copies of their data. It's not unusual. It sounds really strange, but it happens. So one of the things you can do with Gridstore, when you're using us for bulk storage, turn on that Reed-Solomon encoding and you get nice high levels of protection without having to have multiple replicas of full sets of your data.
Okay, so that grid protect level is
it's based on
device losses before data loss?
Yes. So if I have 9 storage nodes, here are my choices. I can do an 8+1, which would give me the equivalent of RAID 5. I can do a 6+2, gives me my RAID 6.
Storage nodes?
Say again?
The RAID stripe is across all the storage nodes, not within a storage node?
Yep, if you want it to be. And it's per Vlun. Okay, it's not for the whole pool. The protection level is on a per Vlun basis.
So when you add the new node?
Yes, and it's a...
Yeah, it's stripe
certainly
across
stripe
the
across nodes. Did I say that incorrectly?
Yeah.
Oh, okay.
So, our RAID is not across the disk, it's across the nodes, storage nodes.
And when you add the node, so you rebalance all the data across
Yes,
the
we do.
nodes?
Yes.
Yes.
So you do new writes on the
Yep, as soon as you add a new storage node to the bottom, we instantly move data sets down onto it and start using its hardware immediately.
The RAID stripe is within a node?
No,
no.
it's across
the
nodes.
nodes.
Yes.
What's on the disk is just data. Okay.
So that's
Disks
something
themselves are
different
not
than the rest of the people because we do this RAID calculation on the client side as opposed to on the storage side.
Yeah.
So if you use 7+1 over 8 boxes, you could have a node failure without an issue.
Yeah, you could have more than a drive failure. Good point. An entire storage node could be kicked out. And each of these nodes has dual hot swap power in the back. So you could actually have more than 9 power supplies out and you're still going. Yeah, that's another advantage you get with the highly parallel nature of the grid. When you have lots of building blocks like that, you get excellent resiliency and fault tolerance.
So what does grid protect level 1 mean?
In this case, it's the equivalent of sort of like a RAID 5. You can take one node failure.
One failure.
Yep.
Yeah, one entire failure. So it could be a node, it could be a network link, it could be a disk.
And overwrites and parity calculations are happening at the client rather than at the server?
Right.
Yeah.
So the I/O is protected before it actually leaves the host.
You just borrow from the hypervisor to supply that calculation?
Sorry?
You just borrow compute from the hypervisor to supply
Absolutely.
Correct.
Yes.
Yep, but each storage node, right, exactly. So that's just, it's a quick calculation. It's an XOR for RAID 5, right?
But you have to go get the data and stuff like that for the XOR. I mean,
No.
No.
Not if you do it properly.
Are you providing a log file structure on the back end? Or?
Yes.
So never overwrite.
Another thing, it's highly optimized for the instruction process set, actually. Yes. So on the client side. So we use AVX and different instruction sets. So.
Okay, but so it's a write in free space structure?
Sorry?
Okay, so if I have 5 nodes at grid protect level 2, and I do a 4K write in the middle of a volume, if that was actually RAID 6, I'd have to read all of the data to be able to recalculate the parity.
Correct.
So, but that would create a lot of network I/O in this kind of environment.
Sure. So for avoiding that kind of issue, whenever we format, we don't do 4K. We try to do larger I/Os to avoid that kind of issues.
Okay, so you're doing
adjust.
like a log-based file system or a write-in free space file system, where you're accumulating multiple.
Sure. We collapse the I/Os basically.
Okay.
We're going to go into a lot more detail on this in a couple slides. So.
Of course you will.
Overall efficiency of all the solution. If I need to build 100 terabyte storage, I need more than 10 units probably, and you consume more than 1 kilowatt and you have 40 cores in the rack. It's a huge amount of CPU power.
Yeah, and we keep them all busy. All the storage nodes are cranking all the time because each one has a quad-core Xeon in it, so we're delivering serious compute power to the grid with each storage node that's added.
Yeah, I don't see it as a big advantage. If you compare it with other solutions, it's very, very inefficient.
So the challenge is with 100 terabytes and so many servers and stuff like that, you're power intensive, you're cooling intensive because of just the way it's structured, right? More so than just 100 terabyte storage array, right?
Our goal isn't deep archive storage. Our goal is IOPS for demanding Hyper-V environments and databases. So this is where you want the hardware.
About the capacity nodes.
Yeah.
So when you talk capacity with other vendors, today you see 50 disks, 60 disks in a single chassis or user chassis.
And that's not the market we're going after. Right, that is the kind of
100 terabytes is a lot for the mid-market customer they're pitching.
Really? Today?
Well,
Yeah.
They're going for the all-use storage, right? Not the bulk storage.
What is the average number of nodes you have on your customer?
6, 8 right now. 6 to 8. Some may be larger.
On the every node, you have 12 terabytes with
Rico, but as you heard, they say the average customer right now is running 6 to 8 nodes. So
Yeah, even if you got to 10 or whatever, like you're 120 terabytes, I mean, it's 85 watts a unit, right? You're 850, like, that's probably half, to be honest, of what some of the large arrays would be.
So we can do power calculations maybe a little bit later, but
and we are going to talk. We are going to talk in the roadmap as well about density.
Yeah. Okay. Everyone's good so far?
Last question.
Okay, yeah.
How big is the PCIe flash card?
550 gigabytes usable.
Okay.
Okay.
And one goes into each storage node, so you start out with a minimum of 1.1 terabytes of flash.
So did you say 550?
Yeah, 550 gigabytes.
I can figure out whose that is from that size.
Oh, that you can.
That's not a normal size.
It's that you can.
It's not.
Okay. So let's roll the video then. So I'm going to go in and create this Vlun 400 gigabytes. And if you could pause right there, because I just want to point out, when you create the Vlun, you can select a server and assign it to the server immediately. A Vlun, now virtual machines can be on priority queues, but there's also physical servers out there, right? So if I have a Vlun that I'm given to a physical server, I might want to put the Vlun on a certain priority queue. You can do that here. Yeah. And so let's just roll it with the space bar.
Server, the storage node? Is that what that is?
No, it's a client.
Right now, what you're looking at is I am in the grid control, and I'm carving a Vlun off of the storage nodes, and I'm presenting that Vlun to Ginger, which it turns out is a Hyper-V host.
A host server.
It's going to come out a little bit later in the demo, so you're one step ahead. Yeah. Thank you.
But it's an important design consideration that this also works for physical servers, and that the QoS also works for physical servers, because reality is, you know, for performance reasons, most of people's important workloads are still sitting on physical servers. So we need to make sure that we can include that and handle it properly.
Chris will argue about that being a good idea.
Under server, you could also choose a cluster.
Yes, these LUNs are cluster shared volumes, so they're good for a cluster of Hyper-V hosts or Windows scale-out file servers. And then, you know, as you're scaling out your sort of NAS heads, you can scale the underlying block storage very naturally underneath. And works very well with all Microsoft clustering as well as spaces. Great. So now we're going to make this Vlun, and we're just going to give it a drive letter. I believe I settled on G in the end. And so there we go. We now have a new drive G being created and being presented to Ginger. And as soon as we're done with that, let's jump right, and there it is, 400 gigabytes. Now let's use the 400 gigabyte G drive that just showed up on Ginger, which is right here. You see it's already formatted. We did that work already. So we'll just open up the drive. You know, here we are on the G drive. Just create a simple text document.
How hard is it to get that drive to all the hosts?
What's that?
Is there an option to say I want this drive to be to everybody?
No, except for a cluster. In a cluster, you would, hang on. In a cluster, you would present a Vlun to multiple physical servers, but that's the only time you would do it. just like you would a nice SCSI LUN, right?
So you don't, like you have a bunch of Hyper-V hosts, you would have a LUN for each one?
Yes, and the other part of that question that sometimes comes up, you do not need to install the virtual controller on each guest virtual machine. You just install it onto the Hyper-V host, and then all of the guests will be able to get down and
Right,
use
but
that.
if I have a Hyper-V cluster, I want to present the one LUN.
It'll be one LUN.
As a
To the
CSG.
cluster.
Yes.
Yep,
It's
exactly.
shared.
Yep.
Yeah,
and that's the whole point is that they're
Yeah.
not now separate Hyper-V hosts. They are a cluster, so they will arbitrate the right, which is the important thing.
A VLAN is on a per server basis, not a per VM basis, or
Per server, yes.
Per
Per
server.
host.
per host?
Yeah.
Yeah, because it's still a LUN, and you still have all the limitations of the number of LUNs you can mount.
Yeah.
And then I'll show you the VM centricity in a second, the Hyper-V awareness. Okay. Great. So we'll just create a simple file, says hello world, tuck that away.
Was the Gridstore in this case a capacity
Pause
storage
here.
or a performance storage?
See, when I did this was done on, what was I using here? It would be the exact same user experience, whether this was a hybrid storage node or capacity.
Yeah.
Wouldn't vary. You take storage nodes, you put them in a pool, you carve out a LUN, you present it to a server. Right? The usual.
Capacity or performance is hard to
Yeah, I remember there was a radio button in the corner. It just said
No, it's
performance
hybrid or
and capacity.
capacity.
IOPS or capacity.
Yes, that allows you to affect the layout. That's sort of like the advanced demo that I'm not giving you.
That's different.
Well, so you think.
We can go into it though. So shall I continue? Let's do something else with the G drive that's on Ginger. Let's go in and create a new Hyper-V virtual machine. So we'll crank up Hyper-V Manager, right-clicking on Ginger, new virtual machine, right? Give it a name.
Vanessa's back, Howard.
This looks like a machine, a Windows wizard.
VM on Gridstore is the name of the virtual machine. So remember that. We need to be sure we point it at the G drive, which we just did, and give it some startup memory, give it some switching fabric so that it can talk to the world.
The VHDX, or is it just
Yeah, it's going to be a VHDX. As soon as this runs its course, 200 gigabyte VHDX. And so there's your summary. And now that virtual machine has been created on Ginger. Now we're going to go in and we're going to take this virtual machine and we're going to put it on a better priority queue. By default, they all get put on the middle priority queue, but there's one higher and one lower. So we're going to go in. First thing, we select the VLUN, and you see here, this is the VLUN we presented to Ginger. But that's not what we want to do here. We want to talk about a virtual machine. So we go in here and just say that we want to edit QoS. You have to check this checkbox that says, this LUN is being presented to a Hyper-V host. Oh, well, in that case, if it's being presented to a Hyper-V host, we can ask the Hyper-V host, what virtual machines do you know about, or cluster? And there's only one, and it's called VM on Gridstore, right? So now we can go in to, on a per virtual machine basis, I just took that VM, put it on a platinum queue, and it's just that simple. Now it'll get a higher quality
And I only have to tell you
service.
that Ginger is a Hyper-V host once, right?
Yes.
What did the checkbox physically do now?
It told us that the LUN was not just, let me do a pause here. The checkbox told us this isn't a LUN going to any old physical server. There's something very special about this physical server. It's a Hyper-V host. So go ahead and ask about all the virtual
Why doesn't
machines.
it know that it's a Hyper-V host? Wouldn't it be able to say?
So you're saying,
Hey, maybe in the future. Right now we have a checkbox.
you're saying that if it had multiple VMs, you could have assigned a different quality of service to each of the VMs?
Yes,
On-
exactly.
On the Ginger VLAN.
Yeah, and it's very effective. If you get a noisy neighbor VM, which George was alluding to at the very beginning, you can put it down on a lower queue. You have some VMs that need a little bit more juice, especially now in R2, where Microsoft lets you go in and set a minimum IOPS reserves and a maximum IOPS limits. We don't have to worry about the maximum IOPS limits. Microsoft will enforce that. But when it comes to minimum IOPS reserves, if a VM isn't getting what it feels it needs, you can put it onto a higher priority queue.
Is there, one of the things I saw is multiple points of administration to achieve this goal. Is there a point at which you're going to integrate some of your external management tools into either VMM or Hyper-V Manager so that there's not having to swap back and forth between?
Yes, the name of the game with Microsoft is to write a storage management provider, and then you automatically can participate in System Center Virtual Machine Manager.
Is that something you guys are doing?
Underway.
Or?
It's underway. Yeah.
Underway, okay.
Not even on the roadmap. The guy over there is writing that.
He actually is. They are. I thought I heard him talking about it. That's the advantage when you come to visit us. So now what we're going to go, okay, so maybe the Vlun that we gave to that Hyper-V host initially, the 400 gigabytes, maybe more virtual machines, they seem to pop up like mushrooms, right? So now maybe we need some more storage. So we're going to go in, and we have, with Gridstore, we have instant Vlun expansion. So I'm going to go in and take the 400 gigabyte Vlun, make it be 500 using the grid control.
Is that thick or thin provision?
To happen, that'll be thick. And
support thin provisioning?
we're working on that. That's next release. And so, let's see, I should be showing. Here we go. Oh, it's still 400. Hit refresh. You know how Disk Manager works. Once you hit refresh, boom, there's the extra 100 that I just grew the Vlun. So right-clicking on the existing 400 gigabyte drive, I just say to Microsoft, hey, expand, the expansion, just take me into that new space. Now it's a 500 gigabyte disk. There's our text document as well as the virtual machine that we created sitting out on that G drive, which is now 500 gigabytes in size. And it's that fast. It's that simple. You don't have to wait for a Vlun to be expanded.
How do I present that disk now to the other hosts?
They will. Everyone who's in the cluster will now see it as a 500 gigabyte drive.
Yeah, it's part of the Hyper-V CSV mechanism.
Yeah, it's that driver.
Yeah, that there's one master that and then if he dies, they elect a new one. So that's how that magic's pulled off.
So that's basically what that tick box is saying, right? Is that you select that saying it's a Hyper-V host on my driver set is presented to every VM, and that gives it that special.
So, Yep. It gives us insight into all the virtual machines themselves by name, the way they were named. Right. So you can imagine,
because of the shared driver set, right?
Excuse me?
Because of the shared driver set?
Yes, it's because we presented the LUN to every member of the Hyper-V cluster.
Okay. But it's more, you check the box to tell them to go query.
To go query it. To go
the
get the
Hyper-V
info.
host to go, what VMs do you have?
Yes.
Right. It was, they saved however many hours of developer time from asking every host, are you a Hyper-V? If you are, what VMs do you have?
I thought it revolved around how the drivers are delivered to every VM.
No.
No,
and let me cover that again. Then the virtual controller is only installed on the Hyper-V host or every member of a Hyper-V cluster. Just the hosts. Okay. The individual virtual machines themselves, they're just looking at this big SAS hard drive and they're happy.
So there's no agents in the guests.
Right. No agents in the guests.
There's an agent on the host.
But you can install the virtual controller even on the VM if you want.
You could if you wanted to. You wouldn't know the difference.
Yes.
Be a little bit slower with all the network stuff.
Like a pass-through device.
It could be a pass-through.
Yeah,
it's going to be slower with the virtual networks and stuff, but it'll work just fine.
Yeah, a few extra kernel transitions. Okay, great. Well, we had 4 storage nodes then, and we were using them. Let's make the grid bigger. So a new node shows up because I plugged it in. It reports into the boss. The boss goes, wait a minute, you need to have the right profile. So we call up the profile we created at the very beginning, slam it down onto the new storage node, and now it is a member in good standing. Along with the other 4 storage nodes, we now have the 5th storage node that's kicked in, health of disks, CPU, and memory, and now we have 5 storage nodes in the pool with a usable capacity of 54 terabytes.
Okay, and I have to click the rebalance button?
And you do not need to you don't need to click the rebalance button. What we will do immediately when that new node is put in is start moving data from the nodes that you were using down onto it so you get best use of it. But let's say you had a set of spindles that had a lot of VLUNs on them and then some other spindles that were hardly being used. If you hit the rebalance button, we'll start moving VLUNs across spindles because we know where the hot spots are. It's an extra level of,
Is that scriptable?
Not at this time.
It will be.
But
you guys are in the Windows world. I need to get everything through PowerShell.
Yeah, exactly. Well, that's what we also get, Howard, when we have the storage management provider. We will automatically, all of the storage management commandlets, all Microsoft administration tools will automatically work with us.
And one thing I want to add, like while we do the rebalance, it's like, so we don't affect the quality of IOs. So it will be at lower priority, basically.
Right.
Yeah, we put that on a quality of service as well. So you can actually rebalance, or
so that's
you can
tin quality of service.
It's what?
Tin, because you have bronze, silver, and gold for my.
It's dirt.
Depends on your
dirt.
day. Yeah. One of the engineers called it wood.
Okay. Yeah.
Okay, so we're going to swap.
And this is just iSCSI protocol, right?
And no, it's all proprietary.
No, not iSCSI. So it's sockets is the communication mechanism between the virtual controller and the individual storage nodes. Now, had we used iSCSI, we wouldn't be able to have all of this secret sauce that we've been talking about, right? iSCSI is one initiator, one target. It's a one-to-one kind of a thing. We want our virtual controller to be able to talk to multiple storage nodes in parallel with no cluster chatter. And we need to be able to tag IOs at the beginning so we know which VM they're from. All that information would get lost if we were pushing it through an iSCSI straw.
How do you know where?
Yeah, the actual scaling out is in the driver.
So it's all something
It's not-
in Ethernet. I don't care.
How do
past
you know
that.
where the
And let
data
me-
is residing on the storage nodes if you're doing some reads and stuff like that?
It's part of the controller logic.
let
So
me
it
add,
knows
it's
how
not
to
in the
read
driver,
from the
it's in
grid.
our agent
Everything
and the
is held
vController.
on the storage. Okay, it's not held in controllers. Metadata and everything
So
is all
vController
held
a
in the
driver
grid.
plus some of
So the
services.
mapping tables are sitting in the
They're mirrored
drivers?
across nodes. No, they're not in the drivers. They load, they get that, then they control it. But it's always in storage on the grid itself. A couple slides, and I'm actually going to come to that and talk you through that.
Yeah, we need to clear up the driver vController.
Yes. So it's not just a driver. We have a bunch of services running on the individual host. That's what we call vControllers. It's a driver plus service.
If you have multiple VMs on a Vlun and you want to optimize a VM, like you showed us to Platinum or whatever, then how do you just optimize that one VM and not the whole Vlun?
Yes, because, well, the way I only showed one VM, so that's why it didn't show up in the demo. But if I had 4 VMs there, you right-click on any given VM, move it onto a different queue, and hit OK.
Yeah, what's the
Doesn't move it
physical
to a different
manifestation
V1.
of that?
No,
Yeah.
it'll stay using its storage, but it'll
So
get
all
a
the
better
V1s are
quality
made up
of service.
let's say you have a hybrid node, they're all made up of the same thing.
I'm just going to come on to that, actually. So
Okay,
let me,
yeah, go
let me
ahead.
walk right
Somewhere
through
there's
that.
got to be some true manipulation of it.
So Howard, just to answer your question, right? This is showing up as a mini store port driver, presents a block device to the hypervisor.
Right.
No change. It's completely transparent to everything above it. Where's the clicker going to? And the key is what we're doing inside that. So we have a simple name for it, the I/O isolator. That's the black box I was talking about before. And what it's doing is actually it is determining where this block of I/O is coming from. And we can do that with 100% accuracy.
So, but the I/O isolator is not part of the mini port driver. It's
This
another.
This driver is actually what's sitting up in the kernel. It's talking to, this is in memory, user.
It's in the user space.
User space.
So there's another service.
Yes.
Yes.
And we have one service per VLAN.
Okay.
Yeah.
Right.
Yeah, one of
So
these
there's-
running
so
per
there's one
VLAN.
So one vController only has to keep track of the mapping for
One VLAN.
Yes.
Yes.
Okay.
So
And
you
then
can have
anybody-
multiple VLANs in the host.
Okay.
Okay. So the key is actually being able to see that I/O come through and then say, okay, who did that come from? And where did that come from?
Right. And so the I/O isolator, because it knows NTFS, interprets
Right.
which VHDX it is.
Correct.
And there's
Okay.
a few other things that we're doing inside, which we're not really going to disclose how we're doing these things, but I can,
You know how I feel about that.
trade secret.
Why do it at this level? If you can do it within the VM, you don't need to determine where it's coming from.
Because we don't want to change anything in the VM. So we could have done this. We could actually load this all the way up to the VM, but then you'd be causing a change in
And
the
it's
guest.
a pain of management because you have so many VMs.
Yeah, sure.
It's a possibility, and it's something that we haven't designed out, and we had thought about doing as an option. You could put effectively this controller up. You can have a hypercall straight to
But then
the hypervisor.
but then you'd have to support a VLAN for every guest,
Yes.
and then you got too many
Then your
VLANs.
management
Exactly, it's a pain
becomes-
of management.
yes.
That's what I was
And
saying.
since you don't do thin, the waste would get ridiculous.
Yes.
That's coming. So thin is right now not there, but it will be coming in 3 months.
Right, no, but yeah, I mean, that's not the only problem.
Sure.
But when you start going, yes, I have 150 VMs, and each one of them has 2 VHDs, so now I need 300 VLANs, it starts getting unwieldy.
Yes.
And it's hard to manage those many LANs.
Yeah.
Right?
Yeah.
So the drivers know where data is residing for reads, and also apparently knows where data is going to go for writes, because it's creating this larger stripe.
Yes.
And each driver, or each each host here will have its own stripe effectively, and other hosts will have their own stripe, and you'll be building this in a buffer effectively during that period of time. Is that how this all works?
Right.
And then how do you control when a host goes down? I mean, is there some mechanism of trying to replicate the data that's in the driver yet to be written to the store?
So if the host goes down, like we are relying on the CSV basically. So if it's like configured for clustered, then yes. Otherwise, no.
Yeah, but if it's configured for cluster,
we're not holding the data for a long period of time. So the data before we confirm, we have that safe somewhere else.
It's not acknowledged, keep in mind though.
I'm sorry?
Writes are not acknowledged until it has gone to storage nodes.
Yes. Yeah, so we're not sitting on that.
But you're waiting effectively till a stripe is created to.
So we do that only for smaller IOs, and this is workload designed for hypervisor. So that would be with the larger stripes. So we wouldn't have that read, modify, write of issues to begin with.
Yes. So your data layout on the backside is different if you want to do small 4K, 8K writes versus something else. So the key is then actually creating these channels. And what you can see is a channel being created. So think of that channel as memory, its thread pools, queue depth, and so on, caching, what we actually want to do, and so on. So, and then what we're doing inside of that is actually looking at the actual I/O pattern coming from VM1, and what can we do to optimize that. And today we're not doing anything real sophisticated. We're not trying to do too much, but if you look at the kind of outer bands of, is it large sequential writes, we can buffer those up differently, and we can move that across the network more efficiently. If it's small 4K reads, we'll queue those up differently. So we're just looking at, the 4 or 5, kind of priority or key kind of I/O patterns that there are, and looking at how we optimize those. Over time, we'll get more and more sophisticated with how and what kind of optimizations we can actually do there. The next, is then looking at, if you look at the channels, now when you start to put priority on this, now we can start to allocate these resources differently. I believe that was kind of the question that you were asking, is what's actually changing here? What are we doing? So again, we can have, a lot higher priority and much larger number of threads to work on these pools over here versus the ones over there. We can allocate more or less memory, again, accordingly. So we have algorithms that are running there and looking at what, usage is happening, what priorities these IOs are coming on, and, allocating that accordingly. The other thing Don mentioned is that we also will see the reserves and the limits that come from Microsoft. So Microsoft has got that now in the hypervisor. The problem is that it can set these, but it's hard for it to affect them, right? All it can really do is say, look, it's not getting enough, and kind of raise a flag. And that's kind of what Don was talking about. If it's not getting enough and it raises a flag, well, now we can actually allocate more. And we can pull from the other side and allocate more over here.
But if you have your H nodes, let's say, which are the hybrid, right, with like SAS and PCIe flash, right?
Yeah.
And something's sitting on SAS, okay, you can give it more, channels or what have you, but it's still not going to be flash, right? So do you move it to flash then, or how does that work? If you push it to platinum, is it getting moved to flash, or are you just allocating more memory and compute to it?
It's getting more memory and compute right now.
At the driver's side, it's not really controlling what's going on in the back end.
So there's still could be something sitting on flash.
It will control it on the other side, and I'll actually come through that.
Got a higher priority just because it's sitting on the flash, right? Even though you've pushed this other VM to platinum.
What we're actually doing is creating effectively socket pools that literally go across the network. So this is actually continuing all the way through down onto the storage. So again, as we take those off, we can prioritize which one's going onto flash first, or later, or not onto flash at all.
So you can specify later, say I want this on flash.
So there's a client side of QoS, which is running on the host side, and there's a server side.
Okay.
So how many overhead do you put on a host? How much does it cost to put a driver on the...
Yeah, running the vController in the Hyper-V host is going to use CPU resources and reduce the VM density. How much?
Sure. So
we're talking, 1-2% in terms of actual use. Because if you think about what we're doing, typically CPU gets less busy when it's waiting for I/O, right? What we're doing is then taking that I/O and moving it in parallel. Okay, so we can actually respond quicker, return control quicker, which is what everybody wants. So we are using some CPU, but we're using it at exactly the right time when it becomes more abundant. And what we're doing is returning control faster. Because if you have to stream all that I/O...
Except that workload, that analysis only really works on a per workload. Because if I've got one I/O-intensive VM and one compute-intensive VM, the fact that you're using computes to service the I/O-intensive VM is stealing it from the compute-intensive VM.
Which is where the QoS comes in. So you can start to balance those things out. You can actually
not if I
allocate
have
more or
an
less
entirely
resource.
compute-bound VM that isn't doing storage I/O at all.
You're going to hit contention somewhere. I mean, is that going to be any different with any other storage?
It's a workload you take into account when you start scaling your cluster. It's a workload you take away from the array.
So you want to know what it is.
Right. Yeah.
I mean, it's CPU you just take away from the array and you put it in a hypervisor. You scale it there instead of in the array.
The array is a
controllers.
separate device. I mean, you're not contending with the array compute resources when you're doing workload activity on the server, right? I mean, you may be contending because of I/O, right?
This is inherent in any
the reality
any
is
client side. Anytime you have the client side providing storage resources.
So our I/O intensive is only the maths on the client side, for which we use highly optimized instruction sets on the processor, which is AVX and MMS.
Yeah.
Okay.
So I don't have a numbers, but we do use some CPU cycles on the client side.
Sure, we have to. Yeah.
You also have some form of protection and isolation for the controller itself. Because, I mean, if the Hyper-V server or even the physical server gets too loaded on CPU, it can impact even the controller itself.
It can. You have to allocate enough resource. I don't know how that's how you can pin that.
So we are not setting affinity to a particular processor.
Yeah, but I mean, even not with affinity, but reserving some CPU cycles or...
Currently, we don't use it, so it's on the fair share basis.
Okay. So it's a server in the base partition. Right? It's not the V controller is not a VM.
No, it's not a VM.
Okay, yeah.
Yes.
It's in the base partition.
Yes.
So you're subject
it's
to
already protected in a way.
Yeah, and you're subject to that scheduler's.
Yes.
So
the fair resource policy.
Forgive me if this was covered and I missed it, but you have a quad-core processor in the hybrid node and another quad-core processor in one of your capacity nodes. If the host is doing most of the heavy lifting, what's actually being processed at the hardware level?
I'm glad you asked that, because you need to think about the virtual controller as a working manager. It's not doing the heavy lifting. Believe me,
Is it
we've set profilers.
hardware?
Let me say this. We've set profilers on each of our storage nodes, and those CPUs, they're honking. We're using 70%, 80% of those CPUs. They're doing real work. So you take a little bit of performance off of the client of the grid, right, to get a virtual controller running, but it's only a working manager. The real storage operations, all the heavy lifting is being done down in the storage nodes, and you're bringing in, as this gentleman pointed out very quickly, 40 Xeon cores. They'll get it done.
Yeah.
Yeah.
So the key about the QoS is that this does work end to end. And you have to have software at both ends to make that work. Okay. This was a question you had around how do we do the protection. So again, you have two elements here. The vPool, which is a physical collection of nodes. Okay, we can have up to 250 in a vPool.
And you can have high capacity and hybrid vPools.
Yes, so you'd have two of those. You could have two, so you could have total 500.
So we don't allow mixing of capacity and hybrid because we have to
Across the
wait for the I/O acknowledgement.
Yes.
So if we,
I understand.
Yeah.
Okay.
So they would be in this pool, okay, but they could not be in the same VLUN. They can't participate together, okay. So when we do the write, what's actually happening is that I/O comes down. We're breaking that up into same number of nodes as there are here. Example is 8. We break that into 8 equal parts, and we encode those parts. We can encode that, as Don said, with one failure like a RAID 5, 2 failures like a RAID 6, or we can use erasure coding to go beyond that. The limit we have is it has to be one less than half of the total nodes. So if we had 10, you could have 4 failures. Okay? Those failures can take part on a disk, a component, okay, a network connection, an entire node. The virtual controller, when it writes, as long as it gets enough confirmations back, it completes its write, acknowledges it, and keeps going. Okay, so it is fault tolerant. If something fails, it will work its way back in, recover. If it was an intermittent failure, say a network connection, it will detect that. It will recall, and replay data that it's missed and rebuild that element of stripe. If a disk goes, it will rebuild the portion of data that was on that disk. Okay.
I mean, the challenge to some extent is that you cannot acknowledge the write until the stripe is written.
Until enough confirmations come back.
So
all right,
number of
so
nodes.
if it's a RAID 1, RAID 5 or something like that,
you'd need 7 of the 8
all
to come
but
back.
one.
Yeah.
Yes. So, but it's being done in parallel. We're not waiting.
I understand
they're not
it's being done in
sequential.
parallel.
And we have a
It's
write
just
back
being,
hash.
it's that workload today, which is an array, is all done at the array, right? Is now being split between the client and server to some extent, to a large extent. I understand. I'm good.
So what the benefits of this is that it actually gives you better protection than RAID. Okay, it's not protecting just disks. It protects the entire node. It protects against network failures and so on. It does not have the cost of replicas. Okay, most scale-out architectures that you look at have replicas, either 2, maybe 3 replicas.
So you look at vSAN, and you'd be crazy to run it at less than 3.
And vSAN is a good example of that. Okay.
So how much is the overhead of your arrays?
So the overhead is the exact same as like RAID. So if it was 8 nodes and 1 redundant, it would be 1 over 7, or 1 over 8, sorry, or 2 over 8, or 3 over 8.
And
so you're talking
about
about
on a
per VLAN basis.
So for your sequential workloads, you could go 10 plus 1.
Yeah.
Yes.
And for your random workloads, you could go
2 plus
3
1.
plus 2.
Yes.
And
exactly.
The challenge when you're adding a node, then you have to split that activity across the new node. So all effectively the stripes have to be brought in.
And no, that's why he was trying to show you the expansion immediately. We do something differently, so we don't have to rebuild the entire RAID while we are adding a new node.
Yeah.
That was the purpose of him showing you expansion, immediate
because
expansion.
it's per stripe, so new stripes start writing across the new node as well, and then.
But there must be activity to go back to the old stripes and reconstruct those.
Yeah.
It will
If you
rebalance
rebalance.
out of band.
Actually, so what we did is, so I had a 400 gigabyte VLAN.
no, I
When I
understand.
created the 100 gigabyte one, that made its own stripe, and then we just concatenated it onto the 400.
But it's not the expansion of the file system as much as just adding a new node to the configuration now forces a restriping of all the data.
I have some slides on all the steps, which I'll show you.
No, there's 2 ways to do it. You can just do an instant expansion, which is we took a new node and added it on. That created more space. Now, out of the additional space above, we create effectively another segment that we add on to that original VLAN.
So we don't do rebuild of the stripe.
Is there a temporary performance?
No, not if you do that model. If you do a rebuild, there's a performance hit, but it's pretty balanced because the effect on the other nodes is actually marginal. It's just like another client reading data from them. But the one node that is doing the rebuild, that's where all the work is taking place. So again, that's where some CPU gets used, is on those rebuilds.
Which is why I want to script it, because I want to rebuild. I want to rebuild VLAN by VLAN from 1 a.m. to 4 a.m. and then start again the next morning.
Yes. And if you do it at 2 in the morning, then you can put them on high priority and get them done quicker. Yeah. Okay. And the other aspect of this is around performance. Okay. So if you look at clustering, it takes a huge performance hit, and I'm just going to talk about that. Oh, we're going to talk about the demo first. I'm going to come back to the clustering side.
All right. So we use diameter. So, So, for this, we're talking about primary storage under Hyper-V. What you're going to be looking at is 8K reads and writes. And so I decided to take diameter and...
You could have been more artificial than that.
Yeah, well, we do have sort of real-world workloads and so forth, but for the sake of this demo, I took 3 of the hybrid storage nodes and said, let me look at my 8 kilobyte random reads, and I hit it with 4 clients.
Start it?
Yeah, sure. Let's just start it. And so get that thing cranked up. Actually, Shri and I did this just yesterday, actually, if you see the date on it. And so there we go. We have 3 hybrid storage nodes, and you can see that they're cranking along at about 38,000. Oh, there we go. Now we have a nice graphic. You can see it that way.
38,000.
38,000 IOPS, which is very respectable. For storage system that is giving you 24 terabytes of usable capacity.
It's the capacity nodes or the hybrid?
These are hybrid storage nodes, so it does have the 1.1 terabytes of flash in there, along with the 24 gigabytes of usable capacity. And so that's what you can expect there. And we unpinned the meter by changing the range there.
Okay,
so then the next interesting thing is
how big is the disk target you're hitting?
It's a 400 gig each.
So 1200 gig. Yes, it all fits in flash.
Well, it was a read, so
we get similar numbers when we go all disk. Yeah.
Okay.
But so it's 400 gigabytes for this. So
there would be a new thing coming with the more nodes, so it won't hit into the flash, but still we get the higher IOPS. You would be seeing later.
Okay.
Okay, so that's 38,000. Just kind of remember that for 3 storage nodes. And one of the joys of the grid is the linear scalability. So now I said, well, let's go in with 6 hybrid storage nodes. Crank those up, same thing, 8K random reads off of a 400 kilobyte LUN, or disk size, let's say, because we did this with raw. And get your graph on that. And you can see the numbers. They move up a little. The cache actually warms up quite quickly. Usually it's within a minute. It's completely warmed up, which is impressive to me. And so you can see the sort of performance that we're getting now with 6 storage nodes.
Okay.
So, around 66 or so.
So it's about 11,000 IOPS per
68.
node.
Yeah. Yeah. Because we're at 68,000 right now on this one.
So this is all over IP connectivity, though, right? Like network cables.
Yeah.
So,
we use 10 gigabit pipes because I didn't want to measure pipe constrictions.
Okay.
I just wanted, make pipes infinite so I can see how fast the storage is.
Is this going?
And so now we're going to go in. We're going to stop the 6 node iometer. We're going to go with 9 hybrid storage nodes. Crank that up, and we're starting out at about 120,000 right off the bat.
What's the workload profile
on that?
So
This is 8K random
to
reads
answer your question,
using iometer.
one node is not getting used for the read because we are only reading from
Oh yeah, we have. And we'll be coming out with information on how many VDI desktops, how many Exchange mailboxes, how many how big and bad of a database can you run, right? At what latencies? So that information will be forthcoming. But 8K random reads is pretty telling of how you're going to perform in a demanding Hyper-V or database environment.
I would disagree.
Oh, you would disagree? Yeah.
100% reads is a completely worthless IO profile for me.
This is mixed.
Yep.
Yeah. I don't care if
this
they're
is all
random
reads.
or not, yeah.
Yeah.
What do you think it should be? 50-50?
Lots of ways to measure it.
At least 80-20.
Yeah.
Very least.
Oh, 60-40 right-oriented. Let's make it VDI and make them suffer.
60-40?
Well, there's
Right?
no such thing as an environment that has 100 reads.
VDI is
Completely
typically like
BS.
55 read. Excuse me, 55 write.
So things vary a little
It's
bit.
more write
but
than read, which is why it makes conventional storage systems crazy, because they're all designed for OLTP, which is the other way around.
Right. And so here we have it then. 3 storage nodes. We're cranking out about 38,000 8K random reads. 6 of them did 68,000. 9 of them did 122,000.
So one thing to add over here is so we are only using 6 node even in the 9 node configurations because we only read the data from the data nodes, not from parity nodes. So it's like 20,000 IOPS per node.
Okay, and that's it.
And you could do better than that by distributing the parity.
Yeah, but the amount of IOPS doesn't matter in this. It's just showing that it's linear scalable.
Parity is not distributed? Parity is not distributed.
It's RAID 4-ish, not RAID 5-ish. Yeah. Or 5-ish Finkel, but that's a whole other story.
No, but for
How much does it cost?
Oh, you got to ask the hard questions, don't you, Scott?
that's a marketing sales question.
And you get a Gridstore.
No, I'm really curious. I mean, we know how much other stuff about cost on a per terabyte or however you guys sell it basis, but
The list price on the capacity is about $1 gigabyte. List price on hybrid is about $1.50
okay.
Per gigabyte.
per gigabyte.
Oh, I was going to say I got a 20 in my pocket. I'll take a stack of them. Okay.
Okay, so just coming back then where I left off, which was talking about the clustering and the difference between clustering. If you look at, again, so this would be a representation of vSAN as a model or any other clustered scale-out storage, where you see, this one, there we go. I/O coming down here, hitting one of the nodes that has been clustered together. This is your typical 3-way replica. What's happening in the background is that's replicating it across the 2 other nodes in the background. Okay, so you've got added latency because it has to wait for those I/Os to complete. It has added cost with the backplane network, the 3 replicas. Okay, more and more capacity being consumed, And it's also wasting 50% of the IOPS in each of those systems. Okay, because for every I/O that's done here, 2 more happen somewhere else in the cluster. So for every write, there's 3 writes. Okay, so it's an expensive way to do it when you look at this from a pure performance and resource utilization perspective. With this model, what we've done is we've eliminated all of that backplane. There is no internode communication. The I/O is actually protected, as it leaves the source. So we break it up, we write it in parallel as it's protected. And so the nodes are doing very little from that perspective. They're basically getting I/O in, sending an acknowledgement back that they got their piece of it. The result is that we can deliver, just with simple math, right, 3x the IOPS at a significantly lower cost. So when it comes to things like virtualization, which is obviously IOPS intensive and latency sensitive, this is a far better model for it, okay, versus that one, which is a very expensive way to actually scale out storage.
As far as like replication services and stuff like that, you depend upon Hyper-V capabilities there?
Correct, yeah.
3x IOPS of what?
Drink your soda.
You're saying 3x IOPS for
anything here, because you're not writing 3 writes basically, and we're doing it in parallel.
It's really write-intensive activity, because any write would have to be replicated multiple times, whereas in this situation, it's not being replicated.
Yes. So there is no internode traffic there between those nodes. They don't talk to each other. They don't worry about each other. They just take the I/O off, that slice of the I/O for them, put it in their cache, and acknowledge. So this is what's happening inside, and this is kind of continuing the picture that we started with on the client side. Again, if you think about those lanes that we're coming across at the top into that virtual pool, you've got physical nodes here. And then inside of each of those nodes, we're continuing that same prioritization scheme. We're allocating memory more or less, again, more threads more or less, to different VMs and coming in. So when a packet, an I/O leaves that virtual controller at the top, we know which VM it came from, and we know which quality of service it's on. Okay? If you think about traditional storage trying to do quality of service, and they're trying to do that inside the storage array without any idea of what's arriving, it's too late, right? All the I/O is already piled up. If you've got somebody who's doing lots of streaming I/O, you're trying to get together some nice small 4K writes, you're just queuing up behind all that streaming I/O. And until it actually gets in, right, the array can't prioritize anything. And so that's a big downside when you look at that. We're continuing that right from the start, right from the VM, and prioritizing it all the way through. And each of these VMs has their own set of sockets, effectively. Think of it as inbound, outbound. The channels are always bidirectional, and they're always isolated.
Wait, did you just say that you're optimizing the block sizes? Or not?
Yes, so we do differentiate between the smaller read versus larger writes, metadata versus...
What happens there? If the application does 4K, 16K, what happens between the controller and the nodes?
Well, so the 4K, since there's an additional cost of read modifier write, we try to coalesce. So we try to, wait some time to hoping we get consecutive, and then we try to coalesce and send it. But let's say now there is more you don't want one VM which is just writing to take the entire network bandwidth. So we control that network bandwidth, because that's most of the common problem, basically. You don't want one VM to take entire network bandwidth. So we prioritize write versus read versus metadata update versus the real data. That's what we are doing right now.
I like that.
Okay.
Yeah.
So the other thing, again, because that I/O is being split across multiple nodes, based on the number of failures you have, we can acknowledge as soon as we actually receive that. So effectively, our responses come at the speed of memory. They don't even have to actually get onto the cache. So as soon as that node receives it, because it actually isn't doing a lot more at that point, it's just saying, I've got it. It sends its portion of the confirmation back. And as soon as the controller has enough confirmations, it reports up, a completion. Okay?
Okay, but that means you can act to an application before the data is in a persistent state.
Yeah.
But we are fault tolerant. Even if that goes down, we can retrieve the data from the other nodes.
Yeah, but if it's all in memory,
if the
and
fault
there's
is
a power failure in
isolated
the
to a
data
single
center,
node, but
gone.
Yeah.
if the idiot electrician turns off the power to the rack because he was looking to see which circuit breaker it was, then I'm going to have corrupt data.
No, you won't. It's only when the confirmation has gone back to the client.
So we haven't acknowledged the write yet until we got enough acknowledgement. But if you're more
No,
than
but if I have
in memory,
if I
it's not
have
on
one
disk.
if I have one rack with 8 of your nodes,
sure,
and those nodes are acknowledging when data is in their memory,
sure,
and the circuit breaker to that rack blows,
right,
that data is lost.
sure, and that's
If you don't have some uninterruptible power supply, correct.
Been there, done that.
Okay.
Don't rely on it.
Sure. And that's
I
basically.
suggest you talk to the guys at Viking about their NVDIM
Okay.
so that it's NVRAM.
Yeah. So it's
in
more
that
like
node.
Like so our target is to give the protection level what the traditional RAID gives. So if you have a one more
RAID
drive
array
failure,
would not acknowledge the write until the data is someplace in a persistent location, whether it's non-VRAM or on disk or battery backed up, whatever.
Yeah.
It's in a persistent place when the write is acknowledged.
How many failovers do you want?
Yes.
If node failover is enough, then this is okay. If you want to have complete rack failover, that's a different question.
exactly.
Yes. And that's a policy. I mean, it's an
Sure,
easy.
and that's something we could do. So we have a knob
that's
basically.
easy to do. It's not.
So we have a knob. Basically, what it can do basically can switch from async mode to synchronous mode. So it basically will go all the way to the flash before getting acknowledged. So we have a knob right now, but we are not using it
It's
for
not
performance.
externalized, right?
Yes.
Yeah.
Okay. If I can choose,
You can't. They can.
We
I'll
can
talk to
expose-
George.
We can expose that. You can choose. On the caching side, it's a persistent write-back cache. Okay,
Right.
so if when node does go down and it comes back up, the data that's still in there is still fresh. We can serve
the
that.
flash is plenty
Okay.
persistent for me.
Yes. And also what we're doing with that write-back cache is then coalescing the IOs before they go to disk and then writing them sequentially out as they're being flushed. So you get nice utilization of the disk in an efficient way.
So sorry, I don't want to go there. I don't want to go there. Sorry. Go ahead.
And then the last part is just as you see at the bottom there is a set of logical containers. So we're actually looking at how we place I/O files onto disk, keeping logical structure so that we can actually do everything on a per VM basis. We do the quality of service and so on. This is the last thing I want to talk about is just because I think it's an interesting topic right now that we have an interesting approach to. People are really looking at server-side write-back cache, okay? And if you're familiar with it, the way that works is you have two pieces of flash and two different physical hosts. You write, you cache it here, but you have to replicate that across to another host so you have a failure, or you can handle the failure. That could be one write or two, depending on whose product you're using, okay? So you have a round trip on a network to get that confirmation back, okay? And then it plays it out of band, or coalesces I/O, and then plays it out of band to storage, which is great for a traditional storage architecture. It doesn't have good write-back cache capability on top of it. But if you look at the resources that are being used, they're quite significant, okay? I'm doubling the amount of network traffic here. So we're talking about using a little bit of CPU in our architecture, okay, versus this, which is doubling the traffic.
Which is also using a little bit of CPU.
Yes. So that's using a lot of CPU, right? Because all that traffic has been doubled, okay? Yeah. You're actually consuming 50% of the flash, okay? The capacity and the IOPS to handle that replica, okay? And the price you're paying for that is to get a round-trip network hop, okay? So that network hop is going to cost you 100 times what the latency of that flash device is, right? Which is measured in microseconds versus milliseconds, close to it.
Depends whose switch you buy.
We're looking at mid-market companies without,
yeah, but I mean,
typical switches.
Typical, I mean,
it's a millisecond round trip.
Like an Arista, yeah, it's a microsecond round trip. If you look at like an Arista 10 gig switch, which isn't more expensive than anybody else's, it's about 700 nanoseconds transit time. So it's 1.2, 1.5 microseconds round trip time. So, I mean, you know, we all think of, you know, the switches we bought 5 years ago, which were an order of magnitude worse than that.
Right.
But 10 gig latency's dropped a lot lately.
So they're converging rather, I mean,
Yeah.
PCI latency,
It's
flash
still
latency versus.
It's still a cost.
Oh yeah, no.
Get that protection.
And the network bandwidth, and you know, and you may decide to go with two replicas instead of one replica, and so
yes, because if you do want to have failover, you want to be on the right host, so it's probably better to have two.
Yeah,
you know, this starts to add up quite significantly.
Yeah, no argument on the general case.
So if you look at our model now, right, where you do a read cache, only a read cache, not a write back cache at the host, and you move the writes through immediately. Okay, you've got a network hop again. Let's say it's the same, right? In reality, we should be able to do that faster because it's in parallel. We're actually splitting that across. Let's say we get a slight gain from that, but the cost is roughly the same. Okay, but now you look at the amount we're actually using. We can deliver probably faster writes. We can do, because we're not consuming half of that cache or the flash device with a replica, we actually now have a lot larger read buffer, read cache sitting there. It's 2x. Okay, so we can serve far more reads from that, which is taking all that traffic off the network. Okay, and we could do it at half the cost.
Okay, and that read cache in the client is from somebody else, right?
Correct.
Okay.
We're not doing it. So I skipped over that. Apologies. We had thought about doing that. The reality is, I did say at the earlier.
My list is 23 vendors that do it now. You don't want to be number 24.
Exactly. So we made a conscious decision not to be number 24. And for that reason, I just see that's going to move to the hypervisors anyways.
Yeah.
Right. It makes sense. That's where it belongs. It's like caching in, caching in the OS. Like, I'm not going to stick somebody's third-party cache into Microsoft's paging system. It doesn't make any sense. Or I'm not going to stick it into Oracle's databases, right? So, if you look at all the way down here, these are just like a waterfall of caches, right from that application all the way through. So what we're doing is using those devices most efficiently to deliver, better performance, both on reads and writes, at a half the price. So I think this is a far better architecture when it comes to actually where you can actually utilize flash.
So is the cache in front of your driver, or behind your driver, or between the driver and the storage?
In front.
That would be in front.
It's in front of the driver.
Yeah, we're the backing store to it.
That would be FlashSoft or something like that.
Cache is in front of our driver.
Yeah, yeah, we're the backing store to it. Just the same as this model would be.
And flash is, on the server side, flash is sitting on front of the disks, basically.
Yeah.
It's a write back, so.
Yeah. Conscious. So you've seen this, the idea that you can scale. The whole idea behind this is that you can scale very small increments, or you can scale in large increments. We did show you kind of what the performance looks like. So as you see it scaling from 3 nodes to 6 nodes to 9 nodes. We haven't done this, so this is an extrapolation. But if you just take those sets, and you were doing the numbers here, whatever, 11,000, just add that up.
In those scenarios, is a RAID 5 kind of RAID 4 configuration with one parity disk, effectively?
Yeah,
they
were all 2
parity
plus
node.
1
Correct.
trees,
Correct.
so RAID 5.
So for the throughput, you would have a higher throughput in case if you have a larger writes and it's a bigger stripe, basically.
Yes.
But for IOPS, it needs to be smaller so that.
Yeah.
So it's a trick, basically, old trick. So.
Did you say 2 plus 1?
Yeah, 2 plus 1 is random IOPS.
That's a very important
Smaller
point,
IOPS.
that these were not measured with mirroring. Right?
Yes.
The parity calculations were being done and delivering those IOPS. So I'm glad you asked the question.
Yeah.
But these are all random reads, so the parity calc.
Writes that MB per second, those had a parity calculations.
Okay. And the last is a couple questions there about what this scales up to. When you actually see the amount of processing power, bandwidth, in this of 1,000 Xeon cores. If you had all 250 nodes here, that's literally 1,000 Xeon cores. 8 terabytes of RAM, 100 terabytes of cache, 5 terabytes of bandwidth into it. So this is really designed for scale, and that's kind of where we're going to. You compare that to the latest EMC, VNX that just came out, which if this was filled to its largest capacity, would give you 3 petabytes, right? That's the amount of processing that we would have relative to it, 31x. the amount of bandwidth into it, memory and flash, right? It's not a fair comparison in terms of performance because I'm extrapolating these numbers out, but on that same basis, this was delivering about 1 million IOPS. Okay, and we would look like around 3.5 to 4 million IOPS if you scaled all the way to 250. Now again, that's extrapolated out. So
we'll be pessimistic and say 3. Okay. Well, I
can accept them. This low value.
Yeah. Well, this architecture.
There's no reason not to scale.
Hit.
It's the isolation. If you notice, the numbers were actually getting faster.
One Vlun is only on so many nodes.
Yes.
Exactly.
It's always going to scale out.
And so.
It's really designed for that kind of scaling.
Yeah.
Very horizontal. And if you did see the numbers, they actually were starting to increase because we're actually spreading more. So the nodes are actually doing less work.
You're
There's less
comparing against an
contention.
all-flash VNX 8000? Is that what you're doing here?
Well, they have so much flash. Whether they have all flash in that, which they can, but I'm not sure how much they have in that.
Yeah, no, that's a hybrid.
Yeah.
It's a hybrid?
Yes.
Yeah. Cache or something?
Yes, it's all hybrid caching. And so, we would probably be about a quarter the price of that.
Yeah.
So how many nodes in that Gridstore configuration?
That would be 250. So that would give you the full
nodes.
3 petabytes of capacity.
That is your actual
versus one VNX 8000.
That is
3
the limit that we
petabytes of
have
data.
right now. Yes.
But
I was really just putting that up there to put it in
context.
context,
You'd
really.
need 5.
Sure.
Sorry?
And we would take maybe more power too.
But they can fit in 3 racks and you'd need 5.
Correct. Our density is not there.
Yeah.
Okay,
Actually
so,
6, but.
But a little less than 6, you're right. Yeah, so we're twice the footprint. Yeah. The last is just looking at the data services. There was a couple questions. I talked early at the start about where we see data services actually moving to, the hypervisor, all of that being controlled on a per VM basis. So what we want to do is be able to optimize and accelerate those types of data services. We don't want them in the storage. We want to accelerate them in the storage. We want them to be driven from the hypervisor and driven on a per VM basis.
So you're relying on the Microsoft snapshot provider?
Correct.
Okay.
Yes. Yes. And we're going to talk a little bit about how we can accelerate some of these things.
So we have some plan, but which we'll share in the closed session. So.
Right.
Yes. Okay.
Okay, and then if I want to do disaster recovery replication, I've got to do it in the host at this stage.
We are addressing in the next version of release.
Yeah.
Okay.
Well, yeah, and the thing is that the whole way you think about disaster recovery changes when you're in a Hyper-V environment. You can turn on these Hyper-V replicas, right? And Microsoft will have the active VM here and a passive one, just sort of asleep over here at the target side. They'll bundle up all the changes within the last 5 to 15 minutes that you're making to the active virtual machine. They'll shoot those over asynchronous replication, right, over to the target and apply them there. Should the primary fail, they'll wake up the target and you're off to the races. So it's really a joy to, I've talked to many customers that are going to Hyper-V specifically for HA and to use these features that Microsoft's bringing, like load balancing, failover, failback, and Hyper-V replicas. It really makes things easy for people.
Yeah.